Welcome to the exciting world of NoSQL databases. In this journey, we will dive deep into the fascinating realm of MongoDB. In this essay, we'll explore MongoDB, a powerful and popular NoSQL database that has revolutionized the way we handle data. Unlike traditional relational databases, MongoDB stores data in flexible documents, allowing for a more dynamic and adaptable data structure. These documents use a JSON-like format, making it easy to work with data in modern applications. JSON, or JavaScript Object Notation, is a lightweight data interchange format that's easy for humans to read and write, and easy for machines to parse and generate. MongoDB's flexibility and scalability make it perfect for handling large amounts of data. It can effortlessly scale up or down, accommodating the needs of both small startups and large enterprises. This is especially important in today's world of big data and real-time applications. With the explosion of data from various sources, having a database that can manage and process this data efficiently is crucial. Whether you're building a mobile app, a social network, or a complex analytics platform, MongoDB can handle your needs. Its versatility makes it a go-to choice for developers across different industries. MongoDB's document-based model aligns well with how we often represent data in programming. This natural alignment simplifies the development process, reducing the time and effort required to manage data. This makes it easier to work with data, as you don't need to translate between different data models. The seamless integration of data models enhances productivity and reduces the likelihood of errors. This also leads to faster development times and more efficient applications. By streamlining the workflow, MongoDB enables teams to focus on innovation and delivering high-quality solutions. Ready to dive in? MongoDB is a powerful, flexible, and scalable NoSQL database that can handle a variety of data types and structures. Let's get MongoDB up and running on your system. Whether you're using Windows, macOS, or Linux, the process is quite similar. First, head over to the official MongoDB website and download the installation package for your operating system. Make sure to choose the correct version that matches your system's architecture. The installation process is straightforward, and you'll find detailed instructions on the MongoDB website. Follow these steps carefully to ensure a smooth installation. Once installed, you can start the MongoDB server. This typically involves running the command in your terminal or command prompt. This command initializes the MongoDB server process, setting up the environment for your databases. This command launches the MongoDB server process, allowing you to connect to it and start working with databases. You can check the server status to ensure everything is running smoothly. Next, you'll want to connect to the MongoDB shell. This is done by running the command in your terminal. This is an interactive command line tool for interacting with your MongoDB instance. It allows you to execute queries, manage databases, and perform administrative tasks. You can use the command to launch the shell and start interacting with your databases. With the MongoDB shell open, you can start creating databases and collections. Use the command to switch to a specific database. A database is a logical container for collections, and a collection is a group of documents. You can use the command to create a new collection within your database. MongoDB's flexible schema design allows you to store data in a way that suits your application's needs. With these basics, you're ready to start exploring the powerful features of MongoDB. Happy coding! Now let's explore the heart of MongoDB collections and documents. Collections are analogous to tables in relational databases, but they offer more flexibility. You can think of a collection as a container for documents that are related to each other. Documents are the fundamental units of data in MongoDB. They are JSON-like objects that store data in key value pairs. This format is highly flexible, allowing you to store different data types within a single document. Here's an example of a document representing a book title: The Hitchhiker's Guide to the Galaxy, author Douglas Adams, year 1979, genres science fiction, comedy. As you can see, documents can contain various data types, including strings, numbers, arrays, and even nested documents. This flexibility makes MongoDB suitable for a wide range of applications. Now that you understand collections and documents, let's dive deeper into how to perform CRUD operations: create, read, update, delete in MongoDB. These operations form the backbone of any database management system and are crucial for handling data efficiently. These operations are essential for managing data in any database system. Without them, it would be impossible to interact with the data stored in your collections. Create. To insert a new document into a collection, you can use the OR methods. These methods are straightforward and allow you to add new data seamlessly. These methods take a document, or an array of documents, as input and add them to the specified collection. This is particularly useful when you need to add multiple records at once. Read. To retrieve data from a collection, you can use the method. This is one of the most commonly used operations in MongoDB. This method allows you to specify criteria for selecting documents based on their content. You can filter the data to retrieve exactly what you need. You can also use projection to specify which fields to include in the results. This helps in optimizing the performance by fetching only the necessary data. Update MongoDB provides the and methods for updating existing documents. These methods are versatile and can be used in various scenarios. You can use these methods to modify specific fields or replace entire documents based on your criteria. This flexibility allows you to keep your data up to date and accurate. Delete. To remove documents from a collection, you can use the OR methods. Deleting data is as important as creating it, especially when dealing with sensitive information. These methods allow you to delete documents that match your specified criteria. This ensures that only the data you no longer need is removed, keeping your database clean and efficient. Section 5. Querying data with filters. Querying data is at the heart of using any database. MongoDB offers a powerful and flexible query language for retrieving data that meets specific criteria. You can use various filters and operators to construct complex queries. Comparison operators. MongoDB provides a set of comparison operators for comparing values. These include operators like equal to, not equal to, greater than, less than, greater than or equal to, and less than or equal to. Logical operators. You can combine multiple query conditions using logical operators like AND. These operators allow you to create more complex and nuanced queries. Element operators. MongoDB offers element operators like and for querying documents based on the presence or type of specific fields. Section 6. Indexing for performance. As your data grows, efficient querying becomes crucial. Indexes in MongoDB play a vital role in speeding up queries. An index is a data structure that improves the speed of data retrieval operations on a database table. When you create an index on a field or set of fields, MongoDB creates a sorted data structure that allows it to quickly locate documents that match your query criteria. Without an index, MongoDB would have to perform a collection scan, which involves examining every document in the collection, leading to slower performance. You can create indexes using the method. This method allows you to specify the field or fields to index and the index type. Section 7. Aggregation Framework. The Aggregation Framework in MongoDB provides a powerful way to perform advanced data analysis and transformations. It allows you to process data records and return computed results. Aggregation operations group values from multiple documents together and can perform a variety of operations on the grouped data to return a single result. You can use aggregation pipelines, which are sequences of aggregation stages, to process data in stages. Each stage performs a specific operation on the data, and the output of one stage becomes the input of the next. Some common aggregation stages include for filtering documents, for grouping documents, for reshaping documents, for sorting documents, and many more. Section 8. Real-world applications. MongoDB's versatility shines in various real-world applications, particularly in computer engineering. For instance, in the Internet of Things, or IoT, MongoDB's scalability and ability to handle time series data make it ideal for storing and analyzing data from IoT devices. For example, a smart home system could use MongoDB to store sensor data from various devices and analyze it to optimize energy consumption. In terms of real-time analytics, MongoDB's performance and ability to handle high-velocity data make it well-suited for real-time analytics applications. Imagine a financial institution using MongoDB to track stock prices in real time and make informed trading decisions. Additionally, in social networks, MongoDB's document model and flexible schema are perfect for representing complex relationships. It can store user profiles, connections, posts, and interactions efficiently. Section 9. Conclusion. Congratulations! You've gained a solid understanding of MongoDB basics. You've learned about its architecture, how to perform CRUD operations, query data effectively, and leverage indexes for performance. You've also explored the Aggregation Framework and seen how MongoDB is used in real-world applications, particularly in computer engineering. As you delve deeper into MongoDB, you'll discover its full potential and how it can empower you to build innovative and scalable applications. Keep experimenting and exploring the vast world of MongoDB,